I'm Yali.
Hi, I'm Meg.
Audrey.
I'm Evan.
And we're the
Group
Xuce! Before we move on to the rest of the video, let's have a brief introduction about the experiment. For soil identification, classification, and strength correlations, we have two limits collectively known as Atterberg's limits. These two limits are the liquid limit and the plastic limit of the soil. In this laboratory experiment, we focused and performed Atterberg's method to determine the plastic limits of a fine-grained soil. The plastic limit is defined as the water content in percent of the weight of the oven dry soil, at which a soil can no longer be deformed by rolling into 3.2 millimeters or 1/8 inch diameter threads without crumbling using a ground glass plate or other acceptable surface. The standard reference that will be used is ASTM D4318 and AASHTO T90, or also known as the standard test method for liquid limit, plastic limit, and plasticity index of soils. This test method is used to characterize the fine-grained fractions of soils and to specify the fine-grained fraction of construction materials as part of numerous engineering classification systems.
So before we start this experiment, let's talk about the materials and apparatus used in this experiment. We have evaporating dishes, which is used to mix specimens to the desired moisture content. We also have spatula, which is used for mixing, forming, and smoothing the soil. We also have wash bottle, which is to dispense mixing water. Aluminum containers, which can be used for the soil moisture samples. Mortar and pestle, used for particle size reduction. We also have liquid limit, plastic limit test accessory set. This includes items needed to run most Atterberg limits test. We also have soil grinder, which is optional for efficient particle size reduction. Digital lab scale or balance with a 0.01 gram readability. Drying laboratory oven for moisture content test.
So here are the procedures for this experiment. First, weigh the remaining empty moisture cans with their lids and record the respective weights and can numbers on the data sheet. Second, take the remaining 1/4 of the original soil sample and add distilled water until the soil is at a consistency where it can be rolled without sticking to the hands. Third step, form the soil into an ellipsoidal mass. Roll the mass between the palm or the fingers and the glass plate. Use sufficient pressure to roll the mass into a thread of uniform diameter by using about 90 strokes per minute. Take note that a stroke is one complete motion of the hand forward and back to the starting position. The thread shall be deformed so that its diameter reaches 3.2 millimeters or 1/8 inches, taking no more than 2 minutes. When the diameter of the thread reaches the correct diameter, break the thread into several pieces. Knead and reform the pieces into ellipsoidal masses and re-roll them. Continue this alternate rolling, gathering, kneading, and re-rolling until the thread crumbles under the pressure required for rolling and can no longer be rolled into 3.2 millimeter diameter thread. Next, gather the portions of the crumbled thread together and place the soil into the moisture can. Then cover it. If the can does not contain at least 6 grams of soil, add soil to the can from the next trial. Immediately weigh the moisture can containing the soil. Record its mass, remove the lid, and place the can into the oven. Leave the moisture can be in the oven for at least 16 hours. Next, repeat steps 3, 4, and 5 at least 2 more times. Determine the water content from each trial by using the same method used in the first laboratory. Remember to use the same balance for all weighing.
Standard test method for liquid limit, plastic limit, and plasticity index of soils, also known as ASTM D4318 and AASHTO T90, shall be utilized as a standard reference. As part of several engineering classification systems, this test technique is used to describe the fine-grained fractions of soil and to specify the fine-grained fractions of building materials. The plastic limit can be calculated using either rolling equipment or hand rolling. The hand rolling technique was applied in this experiment. This continues to adhere the accepted test procedure for the specified range of soils. Rolling the wet soil into thread-like structures measuring 3.2 mm diameter as stated in the standard reference was followed. The water content of trials 1, 2, and 3 are 43.5%, 52.2%, and 39.9%.